Application problem here. We have a management of a company that manufactures skateboards has a fixed cost of 0 output of 300 per day, a total cost of 4,300 per day, an output of 100 skateboards. So we'll automatically see that we got order pair going on. We're going to assume C is the linearly related to output. So C is the cost to output X. All right, so what we're going to do on A is we're going to find the slope of the line joining the points associated with the outputs of 0, 100. So remember, this is X. That is the line passing through these particular order pairs. So we got the output of 0 versus the cost of 300, output of 100 versus the 4,300. That's where the order pair came from. So what I'm going to do is I'm going to find the slope. Kind of gives me an idea. If it's a positive slope, then I know that I got a profit going on or a gain somewhere. If it's a negative, then that means I got a loss going on. Like it's a 0, I got a break even. So we're going to take our order pair x1, comma, y1, and x2, y2. So we're going to take y2, which is 4,300, minus the y1, which is 300. We're going to take the x2, which is 100, minus the x1, which is 0. 4,300 minus 300 is 4,000. 100 minus 0 is 100. 4,000 divided by 100 is 40. So now I know the slope. So we're good. We got that answer. So, and it's a, it's a gain there. That's a positive number. Now we're going to find an equation of the line relating to the output cost. So we want to write it in the slope-intercept form where C represents my cost. Well, we know what the slope is. It's 40. And what is my y-intercept? What is B here? Well, go back to that order pair. They made it so much easier for you. If you notice here, the order pair is 0, comma, 300. That tells me the y-intercept. So it's plus 3, 300 is positive. So I got my answer here. It saved a lot, right? C says, let's graph it. This is not a really great graph to graph on because it's gonna be more like this, and my tables are not big, but we can say each unit represents a particular point if you want. You can say it goes by 20s, but it needs to be bigger. So what I'm going to do is say 2,000, 4,000. I'm going to go 6, and then I'm going to say 8,000. And then over here, I'm going to go 100, 200. And this is my output. Again, that's my X, and then my cost. All right. So when we graph that, we're going to the order pair where it actually crosses 0, 300, and you can start plugging in points. So if I was to take this here, right, and I can say, well, let's plug in 200 for X. Right, that's what I did right here. I plugged in some point because it's bigger than 100. 100 is what they, was that order pair that was given us. Oh, what else does it tell me? It says X can equal 0, but greater than, can be less than 200, but equal to 200. So that's another point to look at. Hey, I'm going to try 200. I'm going to do that. I get 8,300. So when I get there, then I know it's going to be a little bit above here. I'm going to have this order pair here, and it's going to go from somewhere about right here, because it's the x-intercept, or excuse me, y-intercept. We're going to say y-intercept somewhere about right here. So this is what we get. So that's graphing the line. All right, so let's do another application problem. Supply and demand. In a free marketplace, a product is determined by the relationship between supply and demand. The price tends to stabilize at the point of intersection of the demand and supply equations. Points that intersect is called the equilibrium point. The point that corresponding price called the equilibrium price, and the common value of the supply demand is called the equilibrium quantity. All right, so on example 11 here, it says application of supply demand, a price of $9 per box of oranges is a supply of 320,000 boxes. A demand is 200,000 boxes at a price of $8.50 per box. A supply of 270,000 boxes is a demand of 300,000 boxes. So we're going to find the price of the equation of the form of P equals MX plus B, where P is the price, X is the corresponding supply in boxes of 1,000. So this would be good to highlight, make a note to the side that will help you. I'm going to use the point slope formula. Sometimes this is easier. Okay, so we're going to use that. When I go back up to my order pair, we're going to find the points, right? In order to determine all this, we need to find them. Well, I know that my order pair is X comma P. Okay, that was given to us right here. P is going to be the Y value here. And we're going to use our data. What do I know? The first set order pair here I get is going to be 320, $9. And the reason why I did that is because it literally stated X is the supply in thousands of the box, right? So we can drop the last 3 zeros off. Just make sure and be careful with your statement, okay? And then the next one tells me that we have 200,000 boxes at 8.5. So I got another order pair here going on of 270, 8.5. So knowing this, I can find my slope, right? So I'm going to take this order pairs and find my slope. So I got 8.5 minus the 9 over 270 minus 320. So what I get, 8.5 minus 9. Yes, that's a negative half. I was double checking. I knew this. And then I'm going to get a negative value here on the denominator of 50. Negative divides negative is going to be a positive, and 0.5 divided by 50 gives me a 0.01. So that's my slope. So I'm going to plug that in here. I know what that is. And I'm going to pick one of the order pairs. It doesn't matter which one you pick, but I'm going to pick the first one. So I got X minus 320. On this other side, I got P minus 9. And then I'm going to start solving by distributing this negative, or not negative, this 0.01 times that X, and then times that negative 320. And that gives me 3.2. And then let's subtract this 9, or add it to both sides. Since it's a positive, or excuse me, since it's a negative here, we want it to go to 0. I'm going to add it. Okay. So now this is what I got going on. So 9 minus 3.2 gives me a positive 5.8. Okay, so that is the price supply equation. This is the equation, price supply equation. We're going to need this to answer some more. Answer part B. Well, in part B, it says find the price demand equation for using the slope intercept form again, for where P is in dollars, X is corresponding to 1,000. We're going to have to find the given data. We notice, what did we notice here at the top? That we had that 200,000 to the 9. Yes. So if we look here, look, we got this 200,000 to the 9. So we're going to have that order pair. So we're going to have another set value. And then if we go back up here, what do I see? I got another order pair here, the 300,000 to the 8.5. So we got two things going on with the $9 and with the $8.5. This is 300. Now let's find its slope. What do I get? I get this negative value for my slope. I'm gonna plug it in and I'm gonna use the first order pair. So now it's in point slope form. I'm gonna distribute this negative 0.05 to everything inside here. And then I'm gonna add the 9. So now I get this equation. Which is the price demand. It's demand. That's better. Equation. Okay, so we got the price supply equation and the price demand equation. You see the difference? And just catching that in the question helps too. See, it says it right there, price and supply. All right, so we're good so far, guys. So now we're going to go to C. It says graph the price supply and the price demand. So when I graph that, I'm going to have to go back and get my equation up here, right? This is good to have it written down. So I got price supply, and then the price demand. And my graph is not really the best one. If you can find one of those sheets that is a whole sheet of graphing paper, I would encourage you to do that. So when I go graph this, we're going to have an intersection where they intersect at, and I'm going to let you graph this on a whole sheet of paper. Again, this is not the best looking one to do it at. We'll get an order pair somewhere in here. So I would strongly encourage you to figure this one out and do this one on your side and holler at me if you got a question about it. Okay, so this next part, what I wanted to do on this is the intersection. We're going to determine what it is. Well, what I'm going to do is I'm going to take these two equations and set them equal to each other and solve for the x. So when I do that, I'm going to add this to both sides because I want all x values on the same side. I'm going to subtract this constant, get it on the same side. All right, so now what I got, 0, 0. And then we got what? 4.2. believe, yes. And then we're going to divide by this. So what does this tell me? All right, my x value here in this order pair. So I strongly encourage you to create your own graph. It's going to be 280. Okay, so now let's find what is our p. So we can pick either one of these equations. You can solve both or whichever one, but we're going to figure it out. So what I'm going to do is just pick the first one, plug in for my x, and solve. What does this give me? It gives me 8.6, and that's going to be my p, which is my y value here. So I know my intersection is this. This is what they have in common. This is where they intersect at on the graph. So the supply demand problem here, the intersection point of the price supply and the price demand lines is called the equilibrium point, and it corresponds to the equilibrium quantity. So this is the equilibrium quantity of 280 and equilibrium price of $8.60.